Welcome back to the channel. This is going to be a cross-site request forgery same-site strict bypass via sibling domain. Let's get into it. Jumping right into things here, if you look down in the description below, my blog is there and you can follow along if you want to see a written solution. But starting off, let's go ahead and access the lab here. I want to read the description. This lab's live chat feature is vulnerable to cross-site WebSocket hijacking. To solve the lab, log into the victim's account. To do this, use the provided exploit server and perform a cross-site WebSocket hijacking attack that exfiltrates the victim's chat history to the default burp collaborator server. The chat history contains the login credentials in plain text. If you haven't done so already, we recommend completing previous topics. All right, well, let's just check it out. First, we're going to review the application, and this is in my burp browser. So every action we take will be logged in the HTTP history, and we can go back and look at the requests. Let's click home. We can view the details of one of these items. My account is a login page. And then if we go to live chat and type something, you can see there is just a chatbot here. How is this working? If we inspect in the browser, we can actually go to the network tab, and here we will see WebSocket data. I'm going to select WS just to filter out everything else. Click refresh. And you can see the WebSocket here, which contains the chat history. Speaking of, let's take a look at the HTTP history in burp. Here we can see our HTTPS requests. And what's important is when we look through here, we will see the login page, the chat page, they all use a cookie session. So this is great because you have to have an application that uses cookie-based session handling in order to conduct a CSRF. If we now go to the chat page here, and we can see that chat.js is called. Well, this is important. What's key to note here is right here. We'll come back to this later, but this is the sibling domain. CMS, which stands for content. I assume it's just, this is like a content server, content managed server. But looking at this, what's very important to notice is chat.js calls and opens a WebSocket to communicate with the server for us. It's a client-side WebSocket. We can see that right here. Function on WebSocket. Great. So we have an idea of what's going on in the application. Let's now try creating and testing a cross-site request with our own WebSocket. All right, let's talk about building out the WebSocket. So our template is provided in the lab descriptions. If you really don't know what to do, you can just look in there. The goal is we want to host this malicious web page that runs JavaScript, which does 5 principal functions. The first thing, it creates a new WebSocket. The second thing, that WebSocket is pointed to our target application and the live chat endpoint in particular. The third thing, we want to send the ready string. The reason we want to send the ready string is you'll see this in the WebSocket history, that the server is waiting for this. We also identified this in chat.js as being the initial listening trigger by the server. The fourth step will be to pass the fetch function to make a callback to our collaborator server. We want to make sure we can actually perform a callback. And then our fifth step will be to post the event data provided by the chat application. And you can see that all here. So I'll go through it again. First, we are creating our WebSocket. That's this line here. Secondly, we're pointing the WebSocket to our chat application, which is defined right here. Third, we're sending the ready string once the WebSocket opens. So that's here. Fourth, we are passing the fetch function here. And this is going to point the target browser. Lastly, we are posting the event data right here. And if we look at chat.js, we'll learn that the event data is where the chat history is being stored. And we're going to post this back to our collaborator server, which is here. And this will be via the fetch function. If we store and deliver this to the victim, here's what you should see in Burp Collaborator. We can see here the data being sent back after 2 DNS requests, but there's not really anything in here. If we actually look at the request to collaborator, you can see here we connected, or we're now chatting with Halpine, but there's no message log. There's no history here. And the reason this won't work and it'll always be a new connection is because it has the SameSite Strict header. If we look in Burp, we'll see the SameSite Strict header is set. I'll show you right now. If we go to our initial landing page here, right here you can see SameSite Strict. So we know that a request from a new link will just always result in a new session. All right, well that brings us to the next step of this lab, and that's going to be to try and bypass the SameSite Strict header via a cross-site scripting attack on the sibling domain. Do you remember that CMS subdomain that we looked at? Let's check it out. We'll go over to our login page here, and we'll just tack on CMS dash, just like this. And it brings us to this new login page. Now we need to check our attack surface area, and we're going to enter the most basic cross-site scripting test command. This is just going to be a script to prompt alert. Let's log in, and there it is. So we can see this page is vulnerable to cross-site scripting, and this is great because we need an injection point ultimately for our attack. The last thing we'll have to do to confirm our attack surface is valid will be to churn our post request to the login page where we pass the XSS payload into a GET request via the query string in the URL. If this is the case, we now have a valid vehicle to deliver our payloads, which will be injected through the cross-site scripting point. The way we can do this is in Burp. If you just go over to request and right-click and say change request. Whoa, first we have to send to repeater. There we go. Now we change the request and we go change request method. There it is. We'll send this off. You can see it changed it up here. And voila. So it looks like it works. And this chat, or sorry, the endpoint, the login endpoint actually accepts a GET request. This is fantastic because this means we can now pass our payload via the command line. We don't have to actually be there using the GUI, looking at the web page. We can just pass this all in one backend command using the fetch function on our malicious web page. All right, so this brings us to the final step of this lab, and that's going to be to chain the exploits together. Okay, so we're going to use this script that we used earlier because this works for creating a WebSocket, sending the ready function, and then passing a fetch command and performing a C2. However, because we want to now pass this as a URL query parameter, we're going to have to actually URL encode this. So let's jump over to CyberChef. Over here on CyberChef, we URL encode the payload. Simple enough. Back to our exploit server, we will now use the following payload in order to point the browser at our endpoints that we choose. And the reason we're doing it this way is because, remember, we don't have access to this computer. So we have to use document.location to point the browser somewhere and tell it to go there, because the user isn't just going to browse there on their own. And we don't want the link on the website. We could put a link up for the user to click, but it's better to do it this way because it just runs the second the user lands on the page. And you can see here, document.location points towards our lab login page. And for our username, this is where we're going to pass our URL encoded script. So let's take our URL encoded script, enter it here, and we'll store this. All right, and we're going to deliver this exploit to the victim and patiently wait. And here is the C2 to our collaborator server, prefaced with the DNS request, and we can now see the HTTP chat history. So it looks like Carlos forgot his password and he was provided this password and name. All right, let's go ahead and log in with those credentials. We log in and it is solved. There we go.